Hello, my name is Pavla Dvoráková and I'm going to speak about multifunctional green roofs, facades and interior elements in a BUS-GoCircular context. Within the BUS-GoCircular project, a circular construction skills qualification framework has been developed, and this QR code you can see on the screen provides the link to the document that describes this qualification framework. Area of multifunctional green roofs, facades and interior elements was chosen to prove that the developed qualification framework can be applied to any area of the construction sector. Multifunctionality in terms of roofs, facades and interior elements means that it combines multiple functions to maximize the return of a roof, facade or an interior element. When speaking about functions, we sometimes use colors. Green represents a construction that carries vegetation and contributes to cooling and insulating properties, improves local air quality, increases biodiversity and in fact returns natural space to the place. Blue represents construction that provides water retention and harvesting and contributes to the delay of stormwater runoff, reduces flooding and enables reuse of rainwater in the place to water green roof or facade or exterior, to reuse water for cleaning or watering interior plants. Yellow generates sustainable energy, power or heat, and contributes to the reduction of energy consumed by the building. It contains, for example, solar or thermal panels or wind turbines. The color red is used for a building that provides social functions, building or a construction. It creates space for neighborly relationships, promotes support networks, and reconciles leisure or parenting with work. Examples can be a rooftop playing ground or bar or a cinema. Gray hosts technical functions. It contributes to freeing up the other space or improving interior. Like an example, it can be an air handling unit on the roof or chimney or exterior elements of heat pumps or cooling units. Green roofs can be of different construction. In general, we distinguish two types of green roofs, extensive and intensive. Sometimes something between these two is called semi-intensive. Extensive is a natural low-maintenance green roof. It contains adapted plant communities, sedum plants, bulbs, wildflowers and succulents. It provides lower contribution to urban climate and biodiversity, lower social co-benefits because it's often inaccessible. But it requires minimal maintenance, as supply of water and nutrition is done mostly through natural processes. Weight of the construction is lower, less technical expertise is needed, and it is easy to implement as a retrofitting method for existing structures. On the other hand, intensive represents parks and gardens, including urban agriculture, and may contain ornamental lawns, summer flowers, demanding shrubs, bushes and trees. It provides higher contribution to urban climate and biodiversity. High social co-benefits, for example, space for recreation and agriculture. But regular maintenance is required in this case. Weight of the construction is higher, higher capital costs are required as well, and also more complex systems and greater expertise is needed for such a construction. Green walls can be of a different construction as well. There are three groups depending where the plant is based. Ground-based facades mean that the plant has its roots in the ground next to the building. When using self-climbing plants, not any supporting construction is needed, but some of the climbing plants require a climbing trellis. Thus, it is possible to green only partial areas of facade along the trellis and even to create patterns on the facade. Other construction is represented by plants based in plant troughs or in any place on the facade. And finally, a wall-bound system where the vegetation is planted directly at the facade and connection to the ground is not needed. What are the green construction benefits? It is reduction of urban heat island and improvement of urban microclimate. Research suggests that we need a 10% increase in green space in our cities to combat climate change. Green roofs or facades can be the way. Another benefit is water retention, because green roofs can significantly reduce the surface runoff volumes. Green roofs can help to reduce flash floods as a consequence of intensive rainfall events. Green roofs have positive effect on thermal performance of the building. They have been shown to significantly reduce the need for air conditioning in summer and can provide a degree of insulation in winter. Airborne particles and pollutants are filtered from the atmosphere by the substrates and vegetation on a green roof, so it improves the air quality. The combination of soil, plants and trapped layers of air within green roof system can act as a sound insulation barrier. Sound waves are absorbed, reflected or deflected. The growing medium tends to block lower sound frequencies, whilst the plants block higher frequencies. Green roofs can provide important refuges for wildlife in urban areas and thus increase biodiversity. It can also protect waterproofing layer. In dense urban environments, there is often a lack of green space for residents. Roof gardens and rooftop parks provide important green spaces to improve the quality of life for urban residents. Roofs are strong enough to provide a space for urban food growing. A well-designed green wall is a natural protective shield against negative impacts and contributes to the prolongation of life of building stock. Climbing plants act like a green curtain. The leaves form a shade structure and protect the surface. The drainage effect of the roots helps to retain the foundations dry. Green walls have a temperature balancing effect. They function as a thermal insulation. In addition, they provide protection against UV radiation, pollutants, dirt, and thereby inhibit the fatigue of materials. Green walls can be an effective, low-cost and low-maintenance facade protection against graffiti as well. Here are some examples of constructions with multiple functions. You can see a park that is on the roof of a collective garage, a roof with technical equipment where every empty space is a green roof, with a green roof with a playground, green parts and technical equipment at the back, and a green roof garden. Here are other examples. A solar green roof, also called bisolar roof, is a combination of photovoltaic panels and a green roof. The integrated mounting solution allows the substrate and vegetation to provide the ballasted installation mechanism. This eliminates the need to penetrate the waterproofing to secure the mounting units directly to the roof itself. This combination has special advantages like increased efficiency of the solar system, increase in biodiversity, protection of waterproof layer from thermal and mechanical stress. Another example are solar green facades. Some special case is a facade or a roof that is green and acts as a root wastewater treatment plant that takes care of the building's wastewater. Another type of constructions are interior green walls. They have potential to influence indoor environment of the buildings. This construction can be in a size of a piece of furniture or nearly in this form, but also it can be a wall construction across several floors. It can be a soil-based wall when plants are planted in a substrate, or it can be hydroponic growing. It can be connected to a blue element in the form of an aquarium, and when the fish are there, the whole system can function as a separate ecosystem, where the fish provide food for the plants and the plants provide food for the fish, while filtering the water. What is needed for the construction? Usually water, electricity, and enough light, daylight, artificial light, or both. The introduction of large numbers of plants into our workspaces and other interior spaces has the potential to be included within the design strategy of spaces. The plants will improve oxygen balance, remove toxins, and balance humidity. The living wall can actively work within the building system, and for example, the number of air changes per hour needed can be reduced because the building is producing some of its own fresh air needs. A well-designed internal living wall can potentially reduce HVAC energy loads. What are other benefits of green indoor elements? It is a positive effect on the indoor environmental quality. It improves indoor air quality as it produces oxygen and consumes carbon dioxide. Plants can filter the air from volatile organic compounds and even particles that are commonly present in the indoor air. Green wall affects the humidity and temperature of the space as well. Plants absorb, diffract, and reflect sound. The balance varies with the frequency at which the sound is generated and the room's physical properties. The number of plants, the size of the plants, and their surface area will all affect its ability to absorb sound. Plants alter room acoustics by reducing the reverberation time. They tend to work better in acoustically live spaces, such as those that have hard surfaces, like marble walls, exposed concrete and stone floors. The environmental benefits of plants in our spaces are good for our physical well-being. Cleaner air means fewer headaches. Being surrounded by plants is also good for our mental health. Our essential connection with nature is often lost or forgotten, particularly during the working week. Viewing plants restores this connection. Another benefit is increased productivity and creativity. Several studies have shown significant benefits in terms of productivity and creativity when we see plants while performing tasks. This leads to a potential return on investment. Greenery indoors influences also our workplace satisfaction. Factors such as natural light, good ventilation, and greenery were found to be the most important factors for workplace satisfaction in office design. Studies prove that provision of an enriched environment will lead to greater workplace satisfaction. This in turn will lead to increased levels of staff retention and a significant reduction in staff turnover, recruitment, and training budgets. So, now you can see that the area of multifunctional green roof, facades, and interior elements is very wide and covers a lot of professions, and a lot of skills, competencies, and knowledge are needed for the design, construction, operation, and maintenance in line with the principles of circular economy. As mentioned at the beginning, within the BUS-GoCircular project, a general task-based qualification framework was developed for circular skills in construction, meaning a set of tasks and corresponding learning outcomes were mapped and connected to relevant professions across the construction value chain. The project offers a practical interpretation of the key elements of the circular economy, made applicable to the construction sector. Based on the general qualification framework for circular construction skills, a context-specific application is made for addressing skills needed to realize, maintain, and reuse multifunctional green roofs, facades, and inner wall elements. This is done to prove that the qualification framework for circular construction skills is flexible enough to address different challenges while sustaining the built environment. The qualification framework contains tasks and subtasks. The 9 tasks are the practical equivalents of the key elements, and you can see their list on the screen. Then there are 71 subtasks that further specify strategies to implement circular multifunctional green roofs, facades, and interior elements in construction. The subtasks are connected to professions on the one hand and to so-called units of learning outcomes on the other. 84 units of learning outcomes are defined. They are broken up into competencies, skills, and knowledge components. On the following 2 slides, there are examples of the tasks, connected subtasks, and units of learning outcomes defined by the knowledge, skills, and competencies together with involved professions. The first task that is listed is Design for the Future, and the selected subtask is Design modular solution for roofs, facades, and interior elements. The professions concerned are mentioned in the pink square on the right side and include civil engineer, architect, building surveyor, landscape architect, green roof facade designer, health and safety advisor, facade design engineer, and electrical engineer. One of the competencies is the design of modular structures so that the components can be disassembled and reused after end of service life. Relevant skills include design of modular structure, write and interpret detachable construction details, prioritize standardized solutions and systems to increase possibilities of reuse, and knowledge why custom-made structures should be avoided and how detachable construction details work is needed. The second example is on the task Rethink the Business Model, with subtask Provide multifunctional green roofs, facades, and interior elements as a service. The professions concerned are repair and maintenance operative, roofers, project developers. One of the competencies is to provide building components as a service instead of as a product. Skills include set up a product business model for building components, provide building components as a service, provide service through a subscription plan with regular payment schemes, and employ take-back schemes. Knowledge of strategies for providing building components as a service is needed. These were the examples that were coming from the Applied Qualification Framework. If you are interested more, you can download the document from the link that is hidden in the QR code on the screen. If you are interested in other results of the project, visit our webpage. Thank you for your attention.